Hello everyone, we are Group 0. Our project topic is performance evaluation of Kubernetes on the cloud computing platform, AWS. Now I will introduce our project through 4 parts: introduction, experiment design, experiment implementation, and conclusion. Firstly, let's take a look at Kubernetes. Kubernetes is a modern containerized application management tool with plenty of advantages. So in this project, we will deploy a Kubernetes cluster on EKS and conduct a series of experiments to test the performance of Kubernetes. The basic environment settings of our experiment are as shown in this table. And we will conduct 3 experiments: benchmark, deploy simple applications, cluster failover, and cluster expansion time testing. At the same time, we will monitor logs and analyze them. Now let's move on to the implementation part of the experiment. In the benchmark, we first conducted memory testing, and we can see that there is no swap used, and it indicates a good memory management. Next, we conducted throughput testing. We used the imperf3 tool to test the bandwidth of the server and client. The network bandwidth is excellent for applications managed by Kubernetes, and the nodes on Kubernetes can both send and receive data at high speeds. In addition, we also conducted network latency testing, indicating good network conditions. In terms of disk, we used FAO to simulate different types of I/O loads. Based on the results, the read and write data rate and IOPS of the disk are at a good level, suitable for handling large files and small-scale random I/O operations. However, the average latency is relatively high, which may have an impact on performance. We also deploy 2 simple applications, CAN and Ingress. This picture shows 2 containers running in a pod. We first create a new Kubernetes cluster and expose container pod. Then we deploy the deployment. Check the pod. Next, we deploy the service. After these operations, we modified the configuration and added a node port 30000. Now we can use the browser to access the port locally. The next application is Ingress. About Ingress development, we use HPA to expand Ingress, verify the Ingress function, and create object. Then we access the domain name. This picture shows that the access is successful. Our research also involves the robustness and scalability of Kubernetes. We evaluated the failover and the expansion time. Based on the results, the average differences between the preset and absence of workloads is 3 seconds, so we can infer that the failover time has little correlation with the workload. Another result shows that the expansion time has less correlation with the workload and greater correlation with the expansion method. During the experiment, we also reviewed monitoring logs. For example, the total number of bytes transferred about read and write operations shown on this page. In conclusion, we have gained a deeper understanding of the performance of Kubernetes. We found that the disk I/O performance inhibited substantial latency, which could become a bottleneck for I/O-intensive applications. Meanwhile, CPU and memory usage remain acceptable, suggesting the capability of Kubernetes to manage computer resources. As for cluster failover and node group expansion, Kubernetes cluster is highly resilient. Among all tools to optimize cluster scaling efficiency, Panther is the better choice, offering significant improvements. Thank you for your watching and listening. If you are interested in our research, our project report can be found on GitHub, and the link is attached here.